In part 2, let's take a look at the evolution of how a storm becomes a hurricane. And in this graph, you see the frequency of Atlantic Basin tropical storms compared to hurricanes. So before the storm becomes a hurricane, it has to pass through a few other stages of development. The previous one is a tropical storm. And you can see of the number of tropical storms here in blue, the proportion of them that actually go on to become hurricanes. So the life cycle of a hurricane begins with something called a tropical disturbance. We'll see in just a moment, this is a little ridge of low pressure that allows for the beginnings of some organization of cumulonimbus clouds around a low pressure cell. And then if conditions are favorable, this tropical disturbance can grow into what's called a tropical depression, and it's defined by its development as well as its wind speeds. So for tropical depression, we're looking at maximum sustained winds of 23 miles per hour or higher. And then if further development continues, the tropical depression can become a tropical storm, and its winds will reach at least 39 miles per hour. And at this point, the storm is assigned a name. And then if that tropical storm continues to develop, it may become a hurricane. Hurricanes' winds reach 74 miles per hour or higher. And if the storm weakens, it's downgraded by reversing the same classification system. So a hurricane that weakens could go back to becoming a tropical storm and on down the line. Here's a picture of a tropical disturbance. It's an organized cluster of cumulonimbus clouds over the ocean, tropical seas, with a center of low pressure. And it's usually triggered by the intertropical convergence zone. Remember that intertropical convergence zone is the band of low pressure cells that live right around the equator but migrate northward in the northern hemisphere summer and migrate southward in the southern hemisphere summer. So here we're seeing the predominant wind flow here, which is an easterly wave, and we get a little ripple in the action, and it causes a weak trough of low pressure. These usually form off of the eastern coast of Africa and then move towards the United States in the direction that you see here. These tropical disturbances are precursors of about 65% of the named Atlantic tropical cyclones. Here's a satellite image that shows several tropical storms in various phases of evolution. You see that we're looking at the Pacific Ocean here, and we see a tropical disturbance, which are kind of hard to identify, but there's cumulonimbus clouds and a bit of circulation developing here. Here's a tropical depression. So again, we've got a little more development from the tropical disturbance stage. Up here is a tropical storm. This one has a name. This one is Amelia, and it's starting to look pretty strong. We've got definite counterclockwise rotation and starting to take on the shape of a hurricane. And then here we have a hurricane. So you see the eye of the storm and all of the different features we talked about in the last part of this lecture. Here are a couple of links that I will make available to you that describe how hurricanes are named. Basically, the names are picked out in advance of hurricane season, and the names alternate through the letters of the alphabet, beginning with A and going through Z. So the first named storm of the season will start with the letter A. This year it was Andrea. And the names alternate between masculine and feminine. So the first storm was Andrea, the next one after that would be a masculine name that starts with the letter B, and so on. And then if if the storm develops into a hurricane, the names are retired, so they're not used again. The trajectories that tropical cyclones follow are often erratic, as this picture shows. They look kind of like crazy pieces of spaghetti on a plate, but they do follow general trends. They typically start to drift westward. So if we look at one of these tracks here, like this purple one, it drifts westward, and then it curves towards the north and the northeast when it reaches the western Atlantic. And that's kind of what happens with all of these. Some of them take a little more erratic path than others, but they all kind of come in at this angle from the east, and then they turn northwards and then northeastwards. Some of the hurricanes are fueled by the warm Gulf Stream, which means that they can stay warm and tropical as they make their way further north. So New England, which is not really in the hurricane formation area, receives the brunt of a lot of strong hurricanes because of these erratic paths. Here are the paths of some named hurricanes. You can see the name of the hurricane and the path that it took. So we saw the satellite imagery for Hurricane Elena. Started off over here in Cuba and came into the Gulf of Mexico, did a little curlicue before hitting landfall in Louisiana and moving on up into the central portion of the United States. And then here's Hurricane Gordon's path. You can see that it did a big curlicue before coming onto land. Once the hurricane comes onto land, you cut off its supply of warm, moist tropical air. So it's just a matter of time before it dissipates, but in that time it can dump a lot of precipitation and cause a lot of damage on the land. Alright, that concludes part 2 of this lecture.